Good afternoon, guys. Yung ating notes ay nasa uble na. So while waiting for the rest, you can have a look at our lecture for today. Please remind me na pinapost ko muna yung recording, ha? Para pagdating ng iba, i-on ko ulit. Oy, guys. Okay, yan. Ayun lang na record. Dapat ata may co-host ako dito, ha, na magpe-press ng recording. Pwede ba yung co-host mag-record? Ha, guys?
Pwede ata, ma'am, pag-host.
Sige. Sino bang pwedeng co-host? Jessa, pwedeng ikaw ang co-host ko? Maaga ka parati sa class eh.
Okay po.
Ikaw magpipisil. So ano, kasalanan mo pag hindi tayo naka-record na.
Pipindutin ko lang po yung record.
Pag nag-start na ako mag-lecture.
Start na. Okay, sige ma'am.
Ano ba kasi guys? Tapos magsalita kayo. Nasa chat. Hindi ko nakikita yung chat. Alam niyo naman yung teacher din kayo, di ba? Pag sa chat, hindi niyo nababasa yan.
May settings po ata na pag simula ng Zoom, naka-record siya automatic.
Oo, pero ubus oras kasi nag-e-edit
okay.
pa ako. Haba-haba ng ng slides. Sandali, wait. Paano ba to? Paano ko i-assign si participants? Wait lang guys. Chat. Participants. Paano ba? Co-host. Ay, teka. Pag gagawin kitang co-host, dun sa mismong setting ng ano na to, no, Jessa? So, ano yung UP Edu
sa meeting mismo.
Oo, I think edit ko muna yung meeting settings pero dito. Ayan. Kasi minsan nawawala rin ako, so at least may co-host in case na blank yung ano ko.
Ma'am, kapag ongoing yata yung meeting, hindi ma-edit yung...
Hindi, oo. After na. So, ano nga ba yung UP Edu PH email mo? Jessa Jane?
JC Miranda 3. May 3 po.
JC Miranda
3.
Okay. Sige. I-edit ko yan natin. Ay! O bahala. Anyway, malinaw naman to, no? So kahit wala tayong na lecture, basahin nyo na lang. Ayusin ko na lang yung may summation dito sa equation 1. Okay? Ayan. Thank you, guys. Alright. So, para dun sa hindi pa nakaka-encounter kung ano ba yan monthly chips na yan, maikling sharing lang kung ano yan. Okay, ito. Share. Yan. Okay. Send. Nangyari kasi, ay, ano ba yan? Yan ang lumabas. Wait, stop. Hindi. Share screen. Stop to. Yan. Share. Yan. Okay. Hindi ko nalagay yung year dito, but this guy here, his name is Albert Mansell. Back in the early 1900s, he's industrialist, but he's very interested in color, and what he did was he systematically cataloged paint chips. Okay, he commissioned an artist to mix paints, and then pinatimpla niya dun sa painter yung dalawang kulay until obvious na magkaiba na yung kulay. Can you imagine that? So say you have pigment yellow, pigment blue. So i-mix ni artist pure yellow muna. Tapos maglalagay siya ng onting-onting blue. Tapos pag kinumpare niya yung dalawang patches, so ipe-paint niya sa isang patch, ipe-paint niya sa another patch, yung bagong combination. Tapos pag obvious yung kulay, yung difference ng kulay, so that's one obvious paint chip na different ng color. So again, magdadagdag siya uli ng konti pang blue. Tapos titignan niya kung okay, obvious na magkaiba na sila kasi visible na yung difference nila. So another patch yon. And onwards. And based on this cataloging of paint chips in different proportions ng colors. Napansin ni Mansell na our perceptual attributes of color can be classified, or rather, there are 3 axes to our perception of color. There's the hue, the chroma, and the value. Okay, so the hue is the hue is the go. Yun. So ito yung Mansell color order system. It's like in a cylindrical space. The hue is the angle, no? It's in a circle. They are the rainbow colors. The z-axis is the value or the brightness. So it ranges from black to white. And the chroma is the radial axis. And chroma is also saturation, is also known as saturation or the purity of color. So the farthest you are away from the center, the purer the color. And the closer you are to the center, the more diluted your color is. So to the point na wala ng kulay, so gray. All right. So yung hue, again, it's the rainbow colors, no, yung RGB, no? And then ang notation niya red, yellow, green, yellow, ganyan, etc. Tapos meron pang gradations ng either 5 or 10R. So ito yung itsura ng bawat hue, tapos may pangalan yung bawat chips na yan. Okay. Tapos may steps pa in between, like 2.5R. Okay? So may steps pa yan. Tapos yung chroma naman, again yun yung purity. So in 0 to integer steps lang yung binibigay niya. Like this, ito yung tsura niyan. Right? So for a certain hue, meron siyang purity, different values of chroma or purity. Okay? And then finally, yung lightness or value. Okay? So numbers lang yan na 0 to 10. Right? So pag pag hinilera mo, this is how you arrange, this is how they arrange the color chips, no? So this is the hue, which is 5Y, tapos the value is the from top to bottom, and then the chroma, ito yung value, no, yung pinakagitna, no? And then the chroma is radially from outside, no? From here to outside, here to outside. So itong other side, so this is just kumbaga one leaf in the Mansell book of colors. Okay? And color opposite sila in this case. Ibig sabihin, 5Y becomes opposite the color wheel ng hue, magiging blue. So from yellowish to bluish. And pag in-arrange mo lahat ng color chips na na-assemble nila, it looks like a color tree. So sometimes this is bought as books or put in books, and because of this unique collection, nakunan na ng spectrum yung bawat colors na to. So essentially, all the colors, there are many pigments for paintings, but all the colors that we obviously can see the difference of are just 1,250 color chips. Okay, and they're in the Mansell color tree or color book. Again, many research institutes have measured the reflectance spectra of each of these color chips. Okay, and yung University of Eastern Finland did that quite accurately, 12-bit. Okay, so yung isang version nila is in 5 nanometer steps from 400 nanometer to 700 nanometer in 5 nanometer steps. Okay, so yun yung Mansell color chips, and it's the basis of the HSV color space, hue, saturation, value color space, which is based on our perception of color, the human perception of color. Now, all right, share ko naman ngayon guys yung data, no? Pakita ko sa Kasi tinanong kanina, paano ba kunin uli yung E sub I? Again, E sub I is just the principal components of the ensemble here. Escape muna and then share ko naman again yung MATLAB online. Share screen. Desktop 2. Sige, desktop 2. Share. Okay. Okay. Re-record na tayo, no? Tama ba? Just checking.
PowerPoint po yung nakalabas.
Stop share na ba ako? Wait. No, stop share. Tama na yan. Wait. Stop share. Share screen. Other desktop. Okay. Can you see my desktop now? Okay. I'm going to my MATLAB online. All right.
Kita na po.
Let's make that other session, shall we? Okay. Teka, ang bagal ng response siya. Wait lang guys. Dapat, na-off ko na yan. Ano nakikita nyo? Ano pa rin? Exiting MATLAB session.
Photometric stereo that
Okay.
MLX, tapos po may dalawang spheres.
Okay. All right. Okay. Thank you. Now let's make a new session here. By the way, I just realized na pwede nating palitan yung view. Kung gusto nyo ng ala Jupyter Notebook, pwede nating palabasin yung plots or yung output inline. Okay. Sa ngayon, ang default niya dito sa gilid lumalabas yung plots or output. Okay. Now guys, nakikita nyo ba dito sa sa current folder ko, nandito na yung Mansell. Okay, dito yan. Sa command window, I can simply just load that. Load Mansell. Pwedeng ganito. Yan. It's a mat file. It's a MATLAB file. So pwede siyang buksan agad. Okay, enter. That's it. Okay. Bakit nag-load yung photometric stereo? Wait lang guys. Guys. All right. Sorry yung images ng photometric stereo lumabas, pero actually tatlo lang yung laman nito. Wait, clear all na ulit. Tingin ko lang. All right, para mag-clear lang yung workspace. Okay, if I load Mansell again, you will see 3 variables ang laman ng file na to. So, yung ating concern is this. Ito yung spectrum, 400 to 700 nanometers in steps of 5. Now, itong S, ito yung notation niya in Mansell color notation. Ito yung pangalan ng bawat chip. And then, itong C naman is yung iba't ibang color space. Kinalculate na nila yung CIE lab, etc., HSB, ganyan, values na gano'n. We don't need that. What we need is this Mansell spectrum. So 61 corresponds to the 61 wavelengths from 400 to 700 in steps of 5 nanometers. 1250 are the chips, all the chips. So if we plot, kung titignan lang natin kung ano itsura ng Mansell, ito yan siya. I think lalabas dito. Saan ba lalabas yun? Take a moment. Medyo marami lang guys. Notice I'm just working on the command window, ano? Of course, you can copy this in the editor para pwedeng ulit-ulitin. Hoy, lumabas ka. Busy pa ba siya? Busy pa po. Hindi pa po lumalabas. Yun. Yun. Yun, no? That's 1,250 reflectances. Pangit. Plot na lang tayo ng isa. Ika. Para lang makita natin yung isa. Okay. Let's just open a new figure window and just plot one of those. So, let's investigate. One cell. So all the wavelengths, no? All 61 rows, and then pick a number from 1 to 1,250. I don't know. Let's do 700. Yeah. Bagal naman. Isa lang na to eh. Hello. Yeah. Ayun. Hindi ko alam kung alam yan, pero apparently parang medyo nasa red. Maybe this is nasa blue-green. Okay. Anyway, so this is a reflectance spectrum, right? Okay. So all of those na nakita nyo kanina, mumultiplyan nyo sa, for example, pick a wave, a light source, kunyari D65. Multiply nyo lang yung D65. Make sure that the spacing of the spectrum is from 400 to 700 in steps of 5 nanometers for that light source. Para element per element multiplication na lang. Now you ask, paano yung PCA nito? Okay? Kasi kailangan nating makalculate yung E sub I. E sub I is the eigenspectra. Kung may eigenphases, merong eigenspectra. Alright. So, ang pwede natin gamitin, marami. We can use PCA or PCA code. Teka, paano nga ba gamitin yon? So, help, natin may PCA dito. Help PCA. Okay. Meron. So, yan. All right. We just call PCA and then that's it. Then we can have the coefficients, the score, the Latin, returns the principal component variances of X in Latin. So pag coefficients, return the principal component coefficients for the N by P data matrix X. Rows of X correspond to observation and the columns to variables. Baliktad yung ating data, guys. Kailangan natin i-transpose. Each column of coef contains coefficient for one principal component. The columns are in descending order in terms of variance. PCA by default centers the data and uses the singular value decomposition. For the non-default options, use the name value pair argument. Okay. Ano yung score? Okay. Returns the principal component score, which is a representation of X in the principal component space. Rows of score correspond to observation, columns to components. Centered data can be reconstructed by score times coefficient. Okay. Okay. All right. So, ang ating principal components ay actually nasa coef. Tama ba? Ano ba? No. Returns the principal component coefficients for the N by P data. Wait, hindi ko maintindihan kung ano ito. Score. Ano ba? Score? Teka lang ha. Ito yung gusto natin. Coef score latent t-squared explained mu. Returns the estimated mean mu when centered is set to true and all zeros when set to false. And all zeros when set to false. Okay. Ano, kakopy ko lang to eh. Control C. Tapos, copy natin dito sa baba. Pero, imbis na X, ang gagamitin natin ay Mansell. Parang nabasa ko dun, guys. Ano daw dapat eh, no? Bawat observation is in the row and bawat variable is in the columns. Eh, baliktad. Ang variables natin nasa row So siguro ita-transpose natin to. To transpose in MATLAB, just do this. Okay? Sa semicolon ko para hindi maglabasan yung yung data, yung output. Medyo magiging messy yan Okay, let's see if it works. Enter. That's it. It's done. And everything is here. Okay? Now, the mu is supposed to be the average. Kasi centered to So, kinalculate na sa atin yung average. Let's plot mu, shall we? Figure 4. Semicolon. Plot mu. It would be the average of all of those. Tama. Ayan. Ayan siya. Next, ano naman yung latent? Or hindi, yung explain. Ito yung importante kasi it tells you the relative contribution of the eigenvalues. Okay? By the way, the latent are your eigenvalues. Ang daming zero, guys, Diba? Ibig sabihin, maraming eigenvectors, maraming correlation, tapos ito, insignificant na yan. Okay? Ito yung eigenvalues, ng daming zero. So we can reduce really this data. Yan yung latent, yung eigenvalues ay nasa latent. Ano naman yung explained? Okay, plot natin explained. Okay. Alright. Yung explained, yung percent contribution ng bawat eigenvector. So the first eigenvector has the largest variance and it contributes 79.6+% to the whole data and on. Now, ano yung sinasabi ko kanina na tingnan mo nga kung ano yung saan magiging percentage na isa, around 95% cumulatively. Ang gagawin natin is kukunin natin yung cumulative sum nitong explained para makita natin pang ilan eigenvector or eigenspectra yung aabot sa 95%. Okay. So, we just get the cumulative sum of explained equals cumulative sum. There's a function like that. Explain. Yeah, guys. There. That's it. Malabas na. Cumulative sum. So remember, yung first is 79,6405. Tapos i-add niya yung susunod. Look, guys. Wala nga 95 Jump agad sa 97, 98, 99. Ooh, wow. So ibig sabihin nito, what does it mean? Aba, pag kumuha tayo ng 5, gumamit lang tayo ng 5 eigenspectra, no? Para i-reconstruct yung data, 99% na siyang good in a way, no? Alright? Yung iba butal-butal na lang syempre, but say for example, sabihin natin, sige, hanggang kailan siya nag 99%? Walang 95 biglang nag-jump Aba, sabihin natin, okay, pang-5. So M equals 5. Piliin natin M equals 5. So 5 eigenspectra. Okay. Yan yung ibig sabihin yun. Latent, mu is average, latent is eigenvalue, explain this percentage contribution ng eigenvalue, and the cumulative sum, you have to do it yourself. Cumulative sum of explain tells you up to how much you want na accuracy in a way. Okay? Now, asan yung eigenvector dito? Yun ba dito dun? Si COF ba yun? Hindi ko sure Ano natin? Plot natin yung COF. Coefficients to in each of these. Yeah, tama. Kasi itong score, ito na yung magiging, pag i-reconstruct mo siya, ito na yung coefficients per se, alright? Ng bawat chips, di ba? 1,250. So, yung COEF, unfortunately, tinawag siyang COEF. I think the principal components are in COEF. So we just need to figure out kung is it in the row or is it in the column. So let's open another figure window, figure 5, and then let's plot the COEFs, shall we? Kabagalan lang ito. Hindi siya mukhang principal components. I think baliktad yung ano natin. Ta-transpose ko lang siya. Don't worry. Ganito lang yan. Mukha ba siyang hindi pa rin siya mukhang hindi siya mukhang ganun. Kinakabahan ako dito. Wait lang guys. Isa na yung principal components namin. Excuse me. Natin yung mga naunang. Plot natin yung first 5. Tsura nito. Parang hindi. Hindi. Wait. What? Wait. Ay. Sorry. Ito ata dapat. Tapos the first 5. Natin lang ha. Excuse me lang po. Nga pa. Pasensya. Ayun! There you go. Lagyan natin ng label. That's, wait. Label. Legend. Yung. O, tama. Data 1, data 2, data 3, data 4. Okay. So, ganun din. Ganito pala dapat. So, the first row are the wavelengths. And the second number, the columns are the eigenvectors. So, sabi dun sa the first to fifth eigenvector. So, you can choose, no? So, sabi dun sa ating cumulative sum, hanggang 5, 99% na. So, all of this, you just add all of this in different proportions, the appropriate proportions. Makukuha mo na yung marireconstruct mo na yung data. Guys, ito na yung eigenspectra. Ito na yung eigenspectra. Okay? Now, kunin natin yung coefficients. Gusto nating ma-reconstruct ito. Okay? Ito siya. Gusto nating ma-reconstruct using a linear superposition of these guys. Tama? Ito, sino to? Ito yung average. Tama ba? Q4 is mu. Parang nag-calculate kanina tayo ng average, di ba guys? Ito ba yung mu? Tama, nag-plot tayo ng mu. So this is the average. Remember guys, pag nagpi-PCA, mini-mean center niya. So ibig sabihin dapat yung ma-reconstruct natin, dadagdagan pa natin ng mu para umurong doon sa dating location niya. Pag mean-centered kasi guys, magkakaroon ng positive and negative values yung mean-centered spectrum. Ang spectrum naman, wala naman negative, di ba? Notice please na itong eigenspectra na to, may negative values and positive values. So ibig sabihin, pag ito lang yung ginamit natin, magkakaroon tayo ng spectrum na may negative values din. Ang kulang lang doon is kailangan nating idagdag yung mu para maurong siya dun sa space na lahat ay positive. Okay? Kung naalala niyo illustration ko, yung cloud of points. Mean center means going in the middle or the mean of that cloud of points. And therefore, you have positive and negative values. Ganun din pag sa spectrum. Okay. So, next question. Paano natin makukuha yung coefficients A1, A2, A3, A4, A5? Di parang dot product lang, guys. Diba kung iisipin nyo, parang vector to, no? Ito rin vector. Okay. So, ang tanong is kung vector yan at vector din to, para mo makuha yung projection nitong vector na to dito sa hypervector na to, di kunin mo yung dot product nila. Right? Okay. So, paano yan? So, alam ko na yung, ilan ba siyang kinuha ko? Ano yung number niya? Lagyan nga natin ng pangalan. Teka, nalimutan ko na. Ano yung plinat ko kanina?
700 po ata, ma'am.
Oh, thank you. Sige, pangalanan natin yan para may pangalan variable natin. So, test. Test equals Mansell. Lahat ng 61 wavelengths niya, 61 indices, pero si number 700. Yan. So, yan. Okay? Alright. So, essentially, si test, i-dot product natin kay PCA 1, 2, 3, 4, 5. Okay? Pangalanan din natin yung PCs natin. No? So, PC equals coef. Ito, capital pala. I'm very sensitive to. Hindi siya. 1 to 5. Okay, guys? Yan na. Okay. So, naka-arrange yung PC natin into a matrix na ganito. So, pag i-dot product natin, parang matrix operation gagawin natin, guys, para automatic lahat ng coefficients makalculate agad. Right? So, pwedeng PC, teka, paano ba? Pwede nating gawin ito, no? PC, i-transpose natin yung PC para 5 by 61 siya. Tama? Tapos, i-multiply natin siya. Matrix multiplication. Walang dot, guys. Pag linagyan niya ng dot, hindi yan mag-work. Element per element multiplication yung may dot dito. Ito matrix multiplication. Itong star na. O times test. Okay? So, dapat mag-work yan. Sige, hindi ko lalagyan ng semicolon para makita natin yung output. The semicolon is just to suppress the output. Work. Ayos. So, ito na yung coefficients, guys. Right? Kikita niyo yan. Ito na yung mga first 5 coefficients. So, ano ngayon? Ito naman yung imumultiply natin, guys, dun sa Ay, wait. Hindi pala nag-bin centered. Mali. May kulang ako, guys. Teka. May kulang natin. Alam nyo, guys, may mali ako. Kinuha ko agad dito. Si test pala dapat tanggalan natin ng mu. Diba? Mean-centered lahat diba, guys? Mali ako. Ulitin ko na lang. Test minus mu. Diba? Mean-centered yung mga data So, ang nire-reconstruct natin dito, dapat mean-centered din. Okay? Ang tsura niya pag mean-centered na siya. Tignan natin. Flat. Test. Dami niya. Wait. Test minus. Ba't isang kater ba yan? Wait lang. Mu test 61. Test minus mu. Bakit 6? Wait lang, guys. Bakit ang mu natin is 61 by 61? Kabahan ako dyan . Test is 61 and mu is 1 by 61. Ay, mali. Joke. Ulitin natin. Dapat pareho lang. Yan. Okay. Ang tinitingnan ko, guys, yung ito. Kanina, nung hindi ko transpose tong mu, tingnan nyo kasi yun, niya, no? Ito, 1 minus 61. Tapos ito, 61 by 1. Dapat pareho sila ng shape para yung expected output is. Ang dami nito Hindi tama yan. But ang daming spectrum yan. Apparently, ginawa niya isa-isa. Multiple copies of that. So this should work. Let's plot this again. This should be just one spectrum. Ayan. Okay. By the way, nag-auto scale si MATLAB Okay, games. Next is gagawin uli natin yung pagkuha ng coefficient. Pero please remember, test less mu. Okay, yan na. Okay, and the ultimate test is by multiplying this to the 5 eigenspectra. Okay? And then summing them up. So ano uli yung eigenspectra natin dito, guys? Yung PC. Okay. So this is 5. There are 5 pieces here. Pag minultiply natin ito, 61. Tapos isa-sum up natin sila, guys. Okay? So here is our PC. There are 5 of them. Each of them will be multiplied by, each spectra will be multiplied by this. Okay? And after that, isa-sum up natin sila. Kasi yun na nga, linear superposition. Okay? So, if I have these coefficients, by the way, lagyan ko nga pala ng coefficient ng pangalan nito. A. So that A is our coefficients. Okay? See it again. So, paano natin i-multiply yung A? Alright. So, pwedeng right away, PC times A. Tama ba? Pwede, no? Yeah. So, and then isa-sum up natin. So, reconstruction, is, teka, una muna ha. Explain ko lang. Pag yung PC, minultiply natin agad ng A, the coefficients. Since 61 by 5, multiplied by 5 by 1, okay lang dapat yan, right? It's like this. Ano yan siya? Ano yung result? What's the answer? It's a 61 by 1. Bakit?
Iyan na po ata yung nakasama na kasi matrix multiply.
Oo nga. Okay. Plot kaya natin to. Ngayon, patong kaya natin to sa figure 6. To do that, may trick dito. Hold on. Yan. Tapos, plot natin. Plot. Ay, ans. Pag wala akong linagay na variable, may automatic variable siyang ginagamit, ans. Pero mapapatungan to, guys, kung may ginawa uli kayo. Anyway, curious lang ako. Tapos gamitan natin ng ibang kulay. Gamitan natin na red. Blue kasi. Oh, ayos ba, guys? Take a look. Kuha shape, di ba, guys? What do you think about that? Okay. Teka, lagyan natin ng ano. Recons. Equals PC. Okay? So at least yan. Oh, hindi pa yan. Teka, di ba nga, nagtanggal tayo ng spectrum, ay ng average. Dapat idagdag uli natin yung average. Recons plus mu. Wait. Diba? Mean center to eh, kaya nagtanggal siya ng average. Kaya dapat balik uli natin yung average, which is the mu. Okay? So that's recons plus. Teka, ano yung itsura ng recons? 61 by 1. Mu is 1 by 61. Again, don't forget to transpose mu para pareho sila ng shape. Okay. This should be our reconstructed spectra, guys. Sino yung spectrum na 700 natin? Ito siya, di ba? Tama ba? Ito yun, ano? Teka, sino ba siya? Ito. Ito yung mu eh. Ito yung 700. Mansell 700. Oh my God! Okay, so nandito tayo sa figure 3. Para magpatong siya, invoke figure 3 and then type hold on para pumatong dun sa plot na yon. Plot, ano yung pangalan niya? Recon plus mu. Okay. And then, oh my God! Pula ulit. Ang itsura nito. Ah! Yes! Ayos ba, guys? That's it. Minus the sharp peaks or the indentations, but more or less the shape is preserved. Don't you agree? Ayos ba, guys? O parang ginawa ko na yung activity mo. Diba? So,
Actually po.
okay. Pero ito yung PC and this is how you do it sa PC. Ang gagawin nyo is, ang ibibigay nyo yung, actually hindi. Ginawa ko yung activity nyo doon sa PC for compression, I think. Pero yung sa inyo, imagine niyo in real life, kukuha kayo ng picture. Kunyari may digital camera kayo, guys. Kunyari may DSLR si Christian na Canon. Tapos alam niya, nahanap ni Christian yung yung spectral sensitivities ng red, green, blue channel ng Canon camera niya. Yan. Alright? Tapos ito, na-compute niya yung mga PCs. Nandito na, di ba? Ito na yun eh. Okay? Alright. Kukuha siya ng picture ng Mansell. Ay, hindi, ng Mansell. Ng Macbeth chart using that same camera. That same camera. O di may RGB. Kuha siya ng isang color dun sa patches na yan. Kuha siya ng isang color. Pili siya dun sa among the 24. Alam niyo yung average RGB nun. Yan. So yun. Di, ang gagawin niya, itong ginawa natin. Di ba? Not quite. Yung linecture ko, yun yung gagawin niya. Okay? But essentially, at least yung first part ng activity, alam niyo na kung paano gawin. Okay? Right. Ganito, pag nag-tutorial ako, I walk you through it. It's okay. So kung gusto niyo ng tutorial na, show you step by step paano ginagawa, sige, sign up for it. Sabihin niyo, ma'am, tutorial tayo ng Friday. Okay, open the Zoom. Okay ba? Ayos ba, guys? That's how you reconstruct a spectrum using, and these are the eigenspectra. Okay? So na yung eigenspectra natin. Ito, the first 5. Okay? Okay. Anyway, recorded naman to, so you can trace it back. Okay, I'm done. Stop share. Ma'am, kailangan po atang i-transpose ang mute. Tama. Yes. Yeah, I learned. Okay. Kanina. Ano pa? Questions? Okay ba, guys? Malinaw ba?
May question po ako.
Sure.
So kailangan po, 'di ba po, by those operations you get profile, yung wavelength, parang wavelength profile. Tapos ang gusto niyo po ay may RGB po. Saan po makuha yung sensitivity profile?
Well,
For channel.
Kaya nga i-simulate natin yung digital camera. Di ba yung
Okay
activity 2, para tayong nag-simulate ng output ng digital camera, di ba? Trinity of color, remember? May database ng spectral sensitivities ng iba't ibang brands ng camera, remember? Di ba? That's why sabi ko doon sa activity procedure, kung ano yung mga nakuha nyo at ginamit nyo doon sa activity 2, yun din yung gamitin nyo para tipid sa trabaho, di ba? Same light source, na-compute nyo na yung digital color. Same light source na lang. Saka color camera sensitivities, di ba? Yes?
Okay po.
Pero sa totoong buhay, kung kunyari, nasa lab tayo, kunyari, meron talaga tayo face-to-face. Ay, papakita ko sa inyo kung paano i-measure yung spectral sensitivity ng camera nyo. Yan. O, dalhin nyo yung smartphone nyo dito. Kunin natin yung spectral sensitivity niya. Tapos, yung Macbeth chart namin dito, papakuha ko kayo ng picture nun. Yan. Tapos, i-calculate yun na yan. So, essentially, imagine niyo pag nag-face-to-face tayo, guys, gawin natin tong experiment na to sa totoong buhay. Then you've converted your smartphone camera into a spectral imager. Okay? Tanong? Tanong pa? Pero for now, ano na muna? Ay, sorry, hindi pa lang naka-share yung chat to everyone. For now, ano na muna? Simulated color camera. Okay. Ayos ba, guys? Tanong?
Yes po.
Sige,
Yes,
tanong pa.
ma'am.
Wala na. Di maaga tayong matatapos ngayon. Okay. Kung wala nang tanong, that's it. Enjoy the activity. And I'll see you when I see you. So kung may tanong ha, kung may gustong mag-tutorial, sabihin nyo lang and we'll open the Zoom on Friday. Okay, going once. Questions? Going twice. Wala nang tanong? Okay, we're done. Okay guys, thank you.
Thank you, ma'am.
Okay,
Thank you po.
bye everybody. Ending for all, okay? Bye.